All right, so let's begin. We are going to go back and redo this slide on how DCF works. All right, you have a new handout for this 6-12 onwards, because there are some changes that were not clear and some people asked questions, and so I decided that instead of answering to just one person, I will redo that in the class. So everybody has this new handout on number 6. And you can discard your old part of that part of the handout so that there is no confusion as to what is right. So the main change is as to how the NAV works, network allocation vector. Right? So there are 3 variables: contention window, backoff timer, and network allocation vector. And how the duration in these things work: RTS, CTS, data, and ACK. So when you announce the RTS, you say I need so much time. That time includes the time for the RTS, for the CIF behind it, for the CTS, for the CIF behind that, for the data frame, for the CIF behind that, and the ACK. The whole thing is included in the duration frame of the RTS. Okay, what it is saying is that I want the permission to be able to use the medium for that long. Although RTS frame is only 1 slot long, but the duration in that will say much longer. Right? Similarly, when the CTS comes, it has a duration which is smaller than RTS, but it is smaller by 2 slots. It simply says that I want the permission, you get the permission to transmit for that much longer from now. Alright? When the data frame is transmitted, it also has a duration field in it, and that will have the duration field equal to what? Anybody? Now that I've told you 2 frames, can you think about what could be in the data frame? Duration field? Is anybody listening? So I told you in CTS, in RTS, it is everything that follows RTS is included. In CTS, everything that follows CTS is included. So in the data frame, what should be the duration? Duration of the data plus the CIF plus the ACK. Right? So suppose the duration of the data frame is 2 slots, it will say 2 plus 1 plus 1, 4 slots. I need the time, I need to occupy the medium for 4 time slots. Yeah.
So how is the time for data known if I didn't receive the answer?
How is the time for the data known?
Doesn't that vary depending on the size?
Yeah, right. So the thing is, the transmitting station knows the size of the data. So when it says RTS, it announces the time.
Oh.
Right? And the CTS is calculated from that one. I mean, the time in CTS is calculated from what is announced in RTS. Then when sending the data, the same, basically, the same time is used, which is left over. And then when the ACK is sent, it simply says, this is the end. Right? I need the time for this duration for myself. All right. So the purpose of that duration field is that everybody doesn't need to do anything for that duration. So everybody basically basically knows that for that long, the medium will be busy. Even if it is not busy, it is considered busy. Understand? So if I send an RTS and I say I want for 10 slots, then 10 slots are gone. You're not going to see, well, this thing is empty and let me use it. No. Once you hear something which says 10 slots is requested, it's gone. CTS says you're guaranteed 8 slots are gone. And so, even though in between those frames there is this CIF duration, nobody is really sensing during that duration. Because that is part of the previous transmission. Right? And if you come in the middle someplace and you basically, when you get the next frame, you know exactly how long is left. So if you get data frame, you know that so much is left. If you get the ACK, you know how much is left. Basically, that's the end of the thing, right? If you get the CTS, so, all right. So if that is clear as to how the NAV is used, NAV is used basically, during the NAV there is no sensing, no backoff, nothing. So NAV is basically a period for waiting, basically. So if you see a frame, there is a duration field in the frame. For that duration, you set your NAV to, NAV is a timer, set your NAV to that value, and then after that time you come back and see what's happening. Is that clear? All right. So let's see. If a frame, so all right, the NAV expires. If the NAV after the NAV expires, then we see if the medium is idle, and for how long? For diffs. Because we are talking about the data frames here. If the medium is idle for diffs, then after that 3, then we look at the backoff timer. So now there are 3 timers: NAVs, diffs, and then we look at the backoff timer. So if the backoff timer is already going on from before, then we continue from there. If it is 0, then we draw a random number. All right? And now, so we have to wait for NAVs to expire, we have to wait for diffs to go through, and we have to wait for backoff timer. All right? The thing about the diffs though is that if the thing becomes busy in the middle or something like that, or you keep sensing, and if you do the backoff, you keep sensing. So while you're doing backoff and the diffs you're sensing, and if thing becomes busy, you stop the backoff timer. Yeah, you were saying something?
I think if the backup timer is 0, then it sends immediately without drawing any random value. But all stations will start with a backup timer of 1. So initially start with the 1, and then if it, so what 0 means is that it already had a backup timer running, and so it becomes 0 by the time it reached that place. So the last slide.
I see. So what you're saying is the first time is always more than 1, more than 0.
Yeah, 1. So every time, the first time it tries to send, it will select something from 1 and 1 to CW, and it will draw a random number and then try to think.
Okay, let me see. Yeah. Okay, let me. Okay. Let me. Actually, I didn't even start this slide. I'm sorry. All right. So let's see.
If CW becomes 0, then it knows that it is already running a backup.
Yeah. Okay.
From before. 0 means send it.
Right. So then this is this has to be 1 on CW. It says, see, in this line it says draw the random number but means 0 and CW.
Yeah.
So it should be 1 and CW, is it?
I think so, because 0 means send it now, right?
0.
Okay, it might draw from 0 to CW, but then when it is 0, the value is 0 of the backup timer value is 0.
Yeah.
It just sends. It doesn't draw any value.
Yeah, right. Hold on. I think there are 2 values here, and this is quite a good comment because there is something like this. I read the standard in very detail, and then it's kind of confusing a little bit. But if you draw a random number 0, then you have finished your backup timer, and then you can transmit right away. Right? But you have to draw a number though.
Yeah, but I thought that it starts from 1. I mean, everybody starts from a minimum of 1 and then keeps drawing things. That's what I thought. Maybe
So, anyway, we'll just go by what is on the slide right now until I change it again. So right now, what we do is, we draw a random number between 0 and the congestion window. If the number comes out 0, then you don't have to do the backoff timer. If the number comes out anything else, then you have to do the backoff timer. And the thing about the backoff timer is it stops if the medium becomes busy and continues after the NAV expires again. So if the medium becomes busy, then you have to wait for another NAV, another diffs. All right. Now it will become clearer after this example, which we did all over again.
A more clearer comment will be that it draws a random number if the backup timer is 0.
It draws a random number.
If the backup timer is not 0. If it is 0, then it is ready to send. I mean, it is already running from some previous value.
Yeah.
It becomes 0 by this time, so I'm ready to send now.
Okay. All right. Yeah.
If it is not
When it becomes 0, yeah, okay, all right. So now let's see here. So here, this, now I have actually, previously in the previous diagram, we had the frame and it was not really clear what that frame was. So now I have labeled them R, C and D, RTS, CTS, data and AC. So when we came here, the data frame was going on from station 1. Okay? Station 2, 3 and 4 came and they really had no idea of when what will happen, because they might have heard it before, but right now they haven't heard anything, so they wait, and when they get this acknowledgement, that acknowledgement says now this frame is finishing. This, let me not call it a frame, this sequence of transmission is ending. Right? So this will say the end of this transmission is right here at 5. So they will come back at 5 and then they will start their diffs. They will start their waiting. At diff time, they will start their backoff number. They will draw a backoff number. And now this one draws a backoff number of 3. This one draws a backoff number of 2. This one draws a backoff number of 1. Right? And therefore, this station will start transmission at 1. And first thing it will send is a request to transmit, RTS. In that RTS, it will say, since it has a data frame which takes 2 slots, it will say that I need 2 plus 1 plus 1, 4 right there, plus 2, 6, plus 2. I need total of 8 slots. Yeah.
How big the data frame is here?
How do you know?
Yeah. It's just say 2 slots for the data frame?
No. This is the transmitting station. Station number 3 has the data frame, so it knows how big it is. So it announces here that I need 8 slots. Does it clear now?
Yeah, no, the only reason I ask is because in the homework you say the slot frame, or the frame is 3 slots. Or
Yeah, right. I have changed the homework too. I have changed the homework too now. So the thing is, it's clearer now in the homework as well. So I'm not using the word frame here for that reason, because previously we had the word frame and that was not really clear, because there is a whole sequence here. There is RTS, CTS, data and AC. And if you start any one of them, and basically when you start always with RTS and then you end with AC. So you need the whole time frame reserved. The confusion was what happens during these idle periods, are these idle periods, and then should we start counting diffs there? And the answer is no. So what happens is, when you get this, it says please wait for 8 slots. So this is saying at 10, that's saying at 9, so it is going to wait until 17. Everybody is going to wait till 17. Alright? And so RTS will be sent. CTS will have how much time in it? Since RTS has 8 slots, asking for 8 slots, CTS will give it how much? 6 slots. So this is the medium will be busy for the next 6 slots. And when the data frame comes, it says that the medium will be busy for the next 4 slots. So if anybody comes in between there, they will know how long to wait. But these stations were already there, so they have been sensing the medium, they are listening to all of this, so they know that they have to wait till 17. All of them have to wait till 17. Now, at 17 the AC is done, and the AC confirms that, yeah, this is the end of everything. Then they start their wait, and they keep sensing it, and they find that for the whole diff period, the thing is empty. If something else comes in, then that starts the whole other timer. But since the NAV has expired, first the NAV has to expire. NAV was the timer which was set to 17. Right? NAV is set by the duration field in the frames. Right? And so once that expires, then we wait for diff diff period to be empty, and then we do the backoff. These 3 things are in series, not in parallel. Right? If NAV is not expired, then you don't do anything about this business. Just let the NAV expire. Once the NAV expires, then you worry about the diffs. Once the diff is done, then you worry about the backoff. Alright? So once the back-off time comes, now we look at our back-off timer. If it is already going, then we finish the previous timer. If it is not going, then basically we are ready to transmit or draw a new number. So let's see here. So this at 17 and actually at 20 the diffs have expired for all of these three. This is done. Now we look at the back-off timer. This has a leftover of 1 time unit. So this was the back-off. This has a leftover of 2 time units. And therefore, after 1 time unit, station 4 will transmit. After 1 time unit, because this back-off timer expires after 1 time unit and the medium is still empty. If the medium becomes busy for some reason, then it will have to again stop its back-off timer. So this will send its RTS, CTS, data, and ACK and all that. In the meantime, station 2 is also sensing the medium and it starts its back-off timer, but after 1 unit of time it finds that the medium is busy. And therefore it stops its back-off timer. So how much is left? Now it is left with 1. And so that 1 unit will be used at the next opportunity for back-off. Alright? So now there are 3 things. One is NAV, then there is diffs, and then there is a back-off. All 3 have to expire. The diffs is not taken into account, it doesn't start until you have finished the NAV. Right? And the back-off is not started until you finish the diffs. And the back-off is basically a thing which kind of, can be stored. I mean, in the sense that if you don't finish it, you use the remaining in the next time. If in the middle another frame comes in, then the NAV timer is started. So here the NAV timer is started by the 2 stations which are not transmitting, 3 stations actually, and they will know how long to wait before we can go back to sense the medium again. So is this clear? David H.
The data, my question is for station 3, how do you know how long the data frame is going to be?
Okay, alright. This question, let me make it clear again. The transmitter always knows how long the data is going to be. The transmitter has the data frame in its hand. Station 3 has the frame in the queue.
The size of the bandwidth filter.
It looks at the frame it needs to transmit. It knows the length, right? So station 3 knows, other stations don't know. But station 3 knows for sure. Right? Based upon that, it requests the medium in RTS. Is that clear? 3 people have asked, so it's probably not clear, but the thing is, it's the same question. How does the station know the data frame length? The data frame is going to come in the future, but no, it's already there. The data frame came right here, at this point, and at that point. Data frame came, and then we know the length, then only we request the medium. Is that clear? Right? So, first of all, is the NAV point clear as to what is NAV and how it is done? NAV is basically based upon the duration declared in the frame. Alright? If somebody declares that I am going to use the medium for 10 units of time, then we set the NAV to 10 and then the medium is busy. Even though the medium becomes empty in between, those are not counted. Those are all busy periods. I could have drawn a solid line here, and that is how it was before, and that's why it was confusing. Yeah.
I have a question about acknowledgement. I can't understand why the acknowledgement in station 4 is for the station 16.
Okay, can you start over again? I didn't understand your question. So, station 1?
Actually, station 1 sender 6 and neither acknowledgement, right? But in station 4, there has a frame says that is.
Okay, alright. So, this data frame is going from station 1 to 4. this data frame is going from station 1 to 4, and let's see, this data frame is 3 units long, and therefore the duration here would be 5. So when this data frame was sent, actually nobody was around at that time, actually, it turns out. At that time, we would have said, I need the medium for 5 units of time. All right? Although it is going to only use 3 and then wait for 1 and then 4 is going to send that acknowledgement. But station 1 says we will keep the media busy for 5 units of time. All right? So station 1 uses 3 units of time. There is a gap of 1 unit of time, and then there is acknowledgement coming from station 4 to station 1 for 1 unit of time.
Why 4 sends the acknowledgement to station 1?
Because the data was going from 1 to 4.